George is has had several careers, and fortunately for us, because he's talking about frogs and amphibians today, he was a herpetologist at UC Davis, is that right?
UCLA.
UCLA, okay, sorry. And you know, then he stepped back from that and he did other stuff, but he's always kept an interest in this, in frogs and amphibians and also lizards. Well, he'll talk more about that later, but or another day, I hope. If this experience hasn't been so bad.
The next one will be easier.
Anyway, so I'd like to introduce George. He'll tell you more if you need to know more. Okay, so here we go. We're recording, and everybody I'm gonna mute everybody, and then I'm gonna unmute you, George. Okay, so hold on. Mute all. Okay.
And then
Okay, and now I'm going to, where'd you go? George, okay, I'm gonna unmute you.
Do you hear me?
Yes, I can hear you.
Okay.
All right, we're ready to go.
Well, so first I want to thank Audrey and some people who might not be on the call, but who helped me with the technology. This has been very harrowing for me. My 5-year-old grandson is far better at this than I am, and the older kids are vastly better than he is. So this has been a big struggle. And there's going to be some pictures of salamanders that are going to be quite tiny, but that's okay. Put up with it. And this all started, I guess you asked me to talk about disappearing amphibians, which is what I think you asked me to talk about, Audrey.
Yes.
And as I got into it, I decided to expand it, just as the last talk that Roger did, which I thought was, from the title, are birds, reptiles. I mean, just a narrow thing, and really covered a lot of evolution. I thought I'd talk a bit about amphibians, one of the neglected groups of vertebrates. I'm very fond of them. And then talk about the pandemic, which is quite sad and quite remarkable. They are the most endangered group of vertebrates for reasons we'll talk about, and for some reasons that we hardly understand. So with that, I will begin, I guess. So we will go to share screen, if I can find that. And that's probably gonna, okay, go share. And that's it, I can, okay. Oh, by the way, I could not find my amphibian shirt. I have a lovely salamander shirt from the Museum of Vertebrate Zoology here on Berkeley. But it seems to have joined I have 7 unpaired socks. So I assume that my washing machine is eating my shirts as well as my socks. I don't know. In any case, I retitled this from simply the pandemic to amphibians for the last few 100 million years, the long yesterday, who they are today, what you might learn something about them and fall in love with them. And talk a bit about the pandemic that's going on right now. And I'm going to begin with a couple of quotes from some people whom I know well. I've kind of stumbled into this and have been known about it since the beginning. This is something that's been going on for since the late 1980s. In 1990, the realization that these things are just blinking out. So I'm going to begin a quote with, and it's going to be tiny, but I will read it. I'm going to read the lower one first. It's from Karen Lips. She was a graduate student when we were living in Costa Rica, in 1990, and we actually put her up. There were various itinerant students who came through. We'll talk a little about our project later. So I was kind of there at the very beginning of some of this research that was going on. She actually stayed at our house for a while before heading off to the field. And so she writes these poignant paragraphs, and I don't know if it's large enough to read, so I will read it. She says, I started my amphibian research a little like Thoreau, living alone in a cabin in the woods and recording the seasonal variation in the natural world. I lived in a shack without plumbing or electricity, an hour away from the closest house, in a cloud forest on the top of a mountain that straddled the border between Costa Rica and Panama. I was living a field biologist's dream and expected to spend my career studying tropical montane amphibians in one of the most beautiful and least studied regions of the world. I couldn't know that my study site in this remote cloud forest would give me a front row seat to one of the most distressing ecological mysteries of our time. And Karen was the first person to really map the wave of the pandemic and actually find dead creatures in her study site. It's actually fairly unusual to walk around and find dead animals. You see some pictures. Then the upper quote, which comes second in, when I reorganized my talk. Dr. David Wake was the director for many years of the Museum of Vertebrate Zoology. He's now an emeritus professor at Berkeley. He is an expert on salamanders, but he is one of probably the main driving force in organizing the coordinated studies that have been going on for the last 30 years in this most unusual and tragic pandemic. And what Dave writes is, while amphibians might appear to be vulnerable to environmental challenges because of their moist skins and life history traits, they're in fact examples of resilience, having survived previous mass extinction events and being successful in diverse habitats, from lowland rainforests to deserts and to extreme high elevations. Their resilience makes it all the more challenging to explain some of the current declines. So we are dealing with all kinds of unknown and challenging situations. What I'm going to do is just have a bunch of pictures and talk about them and illustrate this talk. So there are three major groups of amphibians today alive. And one of them everybody knows. Even a 4-year-old would know that these are frogs. This is a very sad story. This is the centerpiece of this story in a sense. This is the golden toad of Costa Rica. It's not only from Costa Rica, but it was undiscovered until the 1960s. And then it was discovered in Monteverde. And if any of you know Costa Rica, that's a highly protected area. It was an area started by actually American pacifist Quakers after World War II, and they're very strong on nature protection. This, lo and behold, this Jay Savage, who was a professor of Dr. Wake, discovered this frog in the 1960s. These are a bunch of males expectantly waiting at their pond, hoping for the best. And here's one who found a girlfriend. The females and the males are, this is unusual in the frog world, extremely dimorphic. They don't look at all alike. Females are larger, they usually are among frogs, and they are mating at the edge of the pond. These photographs were taken in the early 1980s. In 1988, I think the last photograph actually was taken in 88 or 87. Yeah, the picture would be 87, 88. The researchers there found a total of 1 frog. In 89, 1 frog, and in 1990, the year we started working there, 0. As far as we know, this frog is completely extinct. It was unknown to science, discovered, abundant in one local area, spectacular, and gone. And so this is the new reality of what's going on with amphibians. It's not just the deadly amphibian disease, but that's a large part of it. And that's part of a mystery that was solved some years later. But it is unfortunately not unusual to go from that scene of massive abundance to dead animals. And as I said, the the then graduate student and now professor at the University of Maryland, named Karen Lips, was the person who actually first went from mapping the distribution in Costa Rica to some of these frogs to finding dead ones, and then to finding essentially none. Well, let's deal with the living amphibians and just talk about it a little bit, who's an amphibian and what. There are, of course, vertebrates. This is a European fire salamander. Europeans had a lot of myths about them. They thought it was a product of fire because you'd burn logs and these things would crawl out. Aristotle said they could extinguish fire, but apparently Pliny did some experiments and threw them in the fire and they burned. So one mystery solved, they're not immortal. And they go through a life cycle. The amphibians typically, and this is a sort of northern hemisphere, I guess we even say in these times in the last few weeks, this is a white person's view of amphibian, typical amphibian biology. I say that, I'm being somewhat sarcastic and funny, but the fact is that the stereotype view of amphibian life cycle comes from biologists in Europe and North America, which have a very limited fauna and whose life cycle is not like most amphibians. We'll talk about that. But here is the North American and European view. They start out as larvae. This is a larval salamander. I say only a mother could love it. They have gills like fish. And they then, as they mature, absorb the gills. Many develop lungs, and they go out and live out there in the world, not necessarily in water. Amphibian is, the word means amphibios. They have two lives, two biological lives: a life in the water where they start, and a terrestrial life. So that's the main story, and we'll see some pictures of that. Also, the fire salamander of Europe, much beloved, is the victim of a fungus, and in Holland, where they were abundant until recently, they're apparently extinct in the last few years. So you have the frogs and the salamanders, and then you have a whole order of amphibians that only biologists would seem to know about or care about. They're kind of ugly. They look like overgrown worms. They're legless, they're tropical, they're called caecilians. Now, my professor, when I took herpetology, had a student, he said, who called them, let's see, not caecilians, but Corsicans. They got mixed up. They're caecilians, and it's spelled C-A-E, and I guess the origin of the word is blind. They have a very limited eyesight. They're burrowing. They're pan-tropical. They're found throughout the tropics. They're an fairly ancient group. But North Americans and Europeans didn't know about them until, well, actually, Linnaeus did. He even named one. But they've never been part of much of our thinking, and they have not been well known and well studied experimentally. So that's a caecilian. Now, if this inspires you to say, I really want to know everything there is to know about amphibians, this is the book you should get. I'm not suggesting that you want to know everything about amphibians, but if you do, Biology of Amphibians by Duhlman and Trueb, and they were husband and wife. It's about 600 pages, and there's literally everything you might want to know about amphibians. It's a great reference book. Not too many color pictures, but it's again, it would be the standard reference for general knowledge. Now, a book that I like is quite different, called War with the Newts. I don't know if any of you know of this book. I'm being somewhat facetious. It's by Karel Čapek. He introduced to the English language the word robot in a science fiction story. He was a Czech. And this is a sort of political satire and science fiction in which some giant newts are found in or near Indonesia, and they're 5 feet long and they can talk. And the political satire, this was written right before World War II, was that although it became clear that they would be out to destroy humanity, a lot of people made a lot of money selling them arms and selling them various supplies so that they could improve and modernize their society. Anyway, it's not important for real amphibian biology, but they don't often make it to the popular world. And this was quite a popular book in the 1930s and a classic in science fiction. So I'm recommending it sort of in jest, but I enjoyed it. And I want to just mention one other book that I think is truly excellent and is also an easier way to do it is This Streams on PBS, Your Inner Fish by Neil Shubin. He's a paleontologist and he's at the University of Chicago, and his interest was the transition, still is, the transition from fish, purely obligate water-living vertebrates, to the conquest of land. And what's really interesting is that although there's some element of looking for a needle in a haystack, there's a lot of science that went into it. So it's no accident that they found what they were looking for. They knew more or less when, historically, what time period these things would have emerged. In other words, they know when amphibian fossils were being found and fish were being found. They knew in what kind of rocks and what kind of exposures. And his first, I guess, great success was the Pennsylvania Turnpike or something. It was a highway where they cut the roads and various geological layers were exposed. So he's quite a engaging speaker, and this definitely streams on PBS, and it's a great book. It really talks about how a scientist thinks through his problems, knew where he wanted to go, went, found it, and how he integrates the fossil world with the modern genetics, because many of the genes that make legs and that make the various bones in the arm and the various bones in your head can be traced directly from fish through amphibians to reptiles and mammals and us. That's why he called it Your Inner Fish. And the guy he discovered, and again, it wasn't a needle in a haystack. They knew exactly what they were looking for. They knew where to go. It was in northern Canada. They named it Tiktaalik, which means something in Inuit. I don't remember what, but it's quite intermediate between a fish and this being a land-living amphibian, and this guy being the intermediate and having the right limb bones, which came from the fins, etc. So I just suggest that as if anybody's interested in a fun read. Now, the Shubin fossil, that the guy who came on land is dated to 375 million years. And that's sort of going back to the quote by David Wake. It's quite ironic that this group that's been through just about everything is now blinking out. They've withstood almost the various major extinctions in the past. So moving on, one group that's been around a long time, 250 million years, we have things that are frogs, just like the modern frogs. And I think that almost anybody finding a fossil like this, not easy to do, but if you found it, you would know it is a frog. So they have maintained a general body form for these hundreds of millions of years, but they've diversified enormously. And they're actually quite many of them are quite spectacular, and they're not quite as popular as birds are. For there are millions of bird watchers. There are not millions of frog watchers. You wouldn't make a lot of money writing a field guide to the frogs of the world, but they are wonderful and wonderfully diverse animals. And they are by far the major, largest of the existing amphibians. They're about 90% are frogs. And so this is just a phylogeny. I won't beat it to death, but showing the presumed branch points of the modern amphibians. You have the Sicilians down here, the guys that look like worms, of which there are about 150 to 200 species, or a couple of major groups. The salamanders, of which we now recognize about 600 or 700 species, and the frogs, which are about several thousand species. So we'll talk a little about this guy, some of the life cycle things in amphibians. By the way, this was stolen from a website, and we're violating laws, so if you want to put me in copyright prison, I didn't call Todd Pearson. But there is something called AmphibiaWeb. Again, for those of you who suddenly get the urge to know as much as possible about amphibians, amphibiaweb.org has photos of every species, has bibliography of almost everything that's ever been written, and access to papers on the modern studies, including the decline. And I just couldn't not show this, for the reason that as I was preparing this talk, now this is quite tiny, but this was approved April 3rd, 2020, and just came out in print. They found a stem salamander, the oldest salamander, so research still goes on, was found just a couple of months ago. So the age of salamanders was thought to be about 115 million years, and then 3 years ago an older one was found in China, 150 million years. Now this guy is 230 million years old, and quite amazing. So again, here's the typical life cycle of, at least as perceived in the northern hemispheres, of an amphibian. The frogs come to ponds to breed, lay eggs in water, have some larvae that are somewhat fish-like, and then they start sprouting legs, front legs, back legs, and in the case of frogs, the tail goes away and you get the adult. That life cycle is found in many temperate zone frogs, but it's different in many tropical. I'll give some examples. So here's just some pictures of this happening. A lovely tadpole. Some of the larger tadpoles, like bullfrogs in the eastern U.S., actually overwinter. The ponds freeze, but they can overwinter as tadpoles. It takes a couple of years, and they transform into little froglets, which have their little paddle-like tail. Legs start emerging, and then the frog. So that's your typical life cycle, and just here's another species just showing the eggs, the larvae absorbing the eggs. They get free swimming, develop their legs, and move on. This is a tropical species, fairly striking. Couple stories about this frog. This is a very common species in the lowlands in Costa Rica, called Dendrobates. This group is very well known because they're called the poison arrow frogs. They have an extremely toxic skin. The indigenous people in South America rub their arrows in it. That's why they're called poison arrow frogs. It's got curare, and they use it for killing prey. But the Dendrobates are very good parents. So unlike the other frogs who lay their eggs in water and go away, and their little babies develop, these have a small clutch size. and the female carries the baby around. She's carrying her little tadpole on her back. And then what they will do is drop the tadpole in a bromeliad, which has water in it, and she'll come by and lay unfertilized eggs for this guy to eat. And then he goes through metamorphosis, he or she becomes a little poison arrow frog and goes out and does it again. So they have a very complicated life cycle, including parental care. And parental care, in some cases, in some of the tropical frogs, is the males. In some cases, it's the females. Just to show salamanders having a similar life cycle, many of the salamanders, this is the newt from the eastern United States. Now, they don't look as different. They look a little like the adults, except they have these external gills, like a fish, but they have legs and a paddle-like tail. This is a very common newt in the east, and then they go through an intermediate stage where they are called efts. They look nothing like the aquatic phase. They live on land. They do this for 2 or 3 years, and then they go back and live their adult lives in the water, but without gills. They have some lungs in here. So they go through this elaborate lifestyle. Now, I will point out that newts in the east and the newts out here are quite toxic. There's something called Tarica toxin. The genus of newts out here is Tarica. And they often have warning coloration. The local birds and snakes will learn not to eat these guys. We have a very rich fauna of salamanders out here in California, and it's particularly richer in the eastern United States. So I'll just show you a few local beasts. Now, unfortunately, I don't know how to make this bigger. This, I would need my 5-year-old grandson. But in a sense, it's good because this is about life size. This is a lungless salamander. The scientific name is Batrachoceps. I should know the common name, but I never learned them. That's one of the problems of being a scientist. These are very common here. It's now discovered there are several number of species. But what's interesting, it's in a family of lungless salamanders. These do not go through the typical life cycle of egg, larva, land stage. The larva gives up its gills. The larva would have gills. These don't have gills. Some don't have gills, have direct development, but they don't have lungs. The whole family are called the lungless salamanders. They breathe through their skin. They have to be moist. And part of this whole amphibian problem, we believe, problem of survival, is that they really are, their skins are really sensitive or highly permeable, and both disease and possibly climate change, and we'll talk about those things, can really do a job on them. So this is this is probably the most common salamander. You turn over logs where it's wet. And you won't get them at this time of year. They go deep into crevices, but in the winter. And this is another larger plethodontid salamander, also from the Bay Area, very pretty. And these are the newts. This is a Northern California newt. And the newts, they're breeding in the botanic gardens. And I know they closed some of the roads in Tilden Park because these migrate to the ponds to breed. There's a very interesting study done by Professor Twitty at Stanford about 30, 40 years ago, probably 40, 50 years ago. Time sort of flies when you get to be my age. But Twitty, the big question is, how do they figure out where they're going? They seem to go back to the ponds where they were born. And how do they get there? And they did all kinds of horrible experiments on them, including blinding them when they get home. And if you cut the olfactory nerve, they don't get home. So they are responding to very faint stimuli in the water and can find their their natal ponds or pieces of stream where they were born. The bright coloration is fairly typical, as I said, of many of these newts. They are poisonous. The local garter snakes will not touch them, but if you bring in a garter snake from someplace that doesn't have newts, they're known to attack them and get sick. They learn fast or die. So these are a few of our local California species. This is too tiny, I'm sorry. There are a number of eastern, the fauna is quite rich in the southern United States. There's some very big salamanders. This is a tiny picture of a siren, which has only front legs, maintains gills, never really metamorphoses to what we call a typical adult. Then I just made some notes for myself, but we sort of talked about it, about parental care. I'm sorry, this is a little out of order, but parental care and reproduction. We talked about that poison dart frog who lays their eggs and they develop on land on the back. There are also a couple of frogs in Australia, one of which has gone extinct right after it was found, just like the golden toad, in which they brood their developing young in their vocal sacs, and then they spit them out when they're hatched. So they have all kinds of weird and amazing life cycles. This is I believe it's a Necturus. It's another of these eastern salamanders that gets fairly large. It's probably about a foot long. They're used in comparative anatomy labs a lot. They're still abundant, and they do not. Many of them do not metamorphose. That is, they do not lose the gills. They're external gills, unlike a fish. This guy is called a Congo eel. They get to almost 3 feet long. They're common in the south. They look like eels, but they have tiny little legs. So just some examples of the diversity. This guy, you can find them in upstate New York and Ohio. It's called the hellbender, also fairly large, you can see, given the person's hand. They're predators. These have huge lifespans. Some of these guys have lived 50, 60, 70 years in captivity. God knows how long they've lived if the next generation of people could keep them. And in this family, there are 2 giant species. Maybe they've been split into a few more species in China and Japan. Now my picture is tiny, but this guy is a full-size person. He's not a tiny person. And this is the Chinese giant salamander. They weigh 50, and at least some sources I say get up to 100 pounds. And their bad luck is that the Chinese like to eat them, particularly as they get rarer and rarer. They seem to be more and more prestigious to eat. So they are driven to near extinction because of this crazy demand on eating rare and endangered animals and show off your wealth, I guess. So that's the local the local world of salamanders. They're quite diverse. Frogs, well, Sicilians, I just show you a couple. They look like worms. I've caught one in my life. This is not something I drove to Costa Rica in 1962 from Berkeley. And on a wet, rainy night in Guatemala, one of these went out on the road. And they're very slimy. I couldn't pick it up, but I was wearing a hat like this. I was able to push it into my hat. This also has been studied. This group has been studied by Dr. Marva Lee Wake, the wife of David Wake, who's also a retired herpetologist here at Berkeley. So this is a major center for studies. And I won't go into any details about what makes a Sicilian, but they're practically blind. They have tiny eyes, but they are vertebrates. They have many, many vertebrae and a regular skull. So interesting group, poorly known. And now we'll talk about, just show you a little diversity of frogs. This is what I would call the archetypal typical frog from the eastern US. We would see green frogs, bullfrogs, and these would have that northern hemisphere reproductive cycle. This is these dendrobatids, these poison arrow frogs, come in different spectacular colors. Sometimes variation within a species and also differences between species. I'm sorry, this is tiny, but this is a close relative of the the red one with the bluish legs, and here's a blue one with black spots. And these are definitely not to be eaten, not to rub your eye. It's sort of like this COVID thing. You don't put your hand on your face if you've been collecting these frogs. This is one of my favorite guys, just in terms of appearance. It's basically a mouth, and it's a horned frog from South America, and they can eat enormous prey relative to their body size. World's largest frog is called the Goliath Frog. It used to be in the genus Rana, like Rana pipia, like the eastern US frogs. They've been split up. You can see from person's hand. Now, these are eaten. It's a food item. It's, again, I would say that the places where I see frogs being eaten mainly have been in Asia, in China, in restaurants, and in France. They love frogs' legs. And bullfrogs have been bred in sort of semi-captivity as food items. So this guy is about 7 pounds. That's not as big as the biggest salamander by a lot, but big enough to be choice. And this is the world's smallest frog. Well, there are arguments. People keep finding smaller and smaller ones. There's some in Borneo and some in New Guinea. They've been turning up recently as adults, breeding adults. So this is a regular sized pencil, and this is the sharpened end. And so you can, this is an adult frog, not a froglet. Finally, frogs have all kinds of adaptations, and many of them are arboreal. And this one's called a flying frog because he can jump to the ground, and he doesn't really fly like the flying squirrel. He spreads his enormously webbed feet. This great photo was taken by Shen Li, whom Audrey and Roger know, coincidence I know, who is an amazing photographer, he was born in Berkeley or Orinda. He's lived in this area, but he's lived in Malaysia and Borneo for years, and he's done fabulous photography. He's a great naturalist. It takes a lot of patience to get a photograph like this. You have to sit and wait for hours until they decide to jump. And you have to be sitting there with your camera ready. I'm going to now kind of switch a little to the story of how I got involved and what we got involved about with these disappearing amphibians. So the story begins, as I said, well, here's me. I look the same right now. I wish. This is me in Costa Rica in 1990, where we were out looking for frogs. And what happened, my role in this has been quite peripheral. I am not a frog biologist or an amphibian biologist, even though their amphibians and reptiles are lumped together in herpetology, but I've always been a lizard guy and a little bit of snakes. But this was not a research trip. I was got a job through Stanford Center of Conservation Biology to really set up a program in Costa Rica to get a field station built to encourage students to come. So it was really an administrative position. It was a great opportunity for the family to come down. My oldest son was in college, but my younger son is 10 years old, and he's became fluent and is still fluent in Spanish. And then he had an easy time learning Italian when he had an Italian girlfriend. So he's done well. The trip did us well. Costa Rica was really advanced compared to most countries in attempting preservation of its forests and doing a great job. And in Costa Rica, we started out with the golden toad. They were in the period of around the late 80s, people were discovering that things were just disappearing. They'd be common 1 year, and the next year they would be gone. So one of the things I got into in developing this field station was working with biologists in Costa Rica who were working on this frog phenomenon. it had been discovered, the disappearance had been discovered right before we got there. In fact, 1990, the year we were there, was the second year, as I said, that nobody found any golden toads. They've never been seen since. So we were down there administering this project and providing housing for itinerant biologists, some from Stanford, some from other places. And that included Dr. Karen Lips, whom I mentioned, who is very important in this world. There was a gentleman there named Alan Pounds, an American, but he's been living in Costa Rica for years, who was very involved in the disappearance of frogs. So jumping back to what was going on in the, well, first, one more thing. My son Philip, this is his project in 5th grade in Costa Rica. He was in a bilingual school, so he could do this in English. I mean, the world was first becoming aware of it, so I'm quite proud that this 10-year-old made this poster of the disappearing frogs. So we won't overblow it. I just mentioned to him the other day that I'd be using this poster, and yeah, he said that was his original research. He wonders how he ever thought of doing it. So that was a joke, obviously. So one of his parents put him onto it, but the awareness was just beginning. So historically, this is what really was happening here in Costa Rica was also happening here. And so you come to the late 1980s, and Dr. Wake, Dave Wake, had a grad student who went up to the Sierras, where there were some very lakes known to have tons of frogs. They're endemic species up there. And this new graduate student couldn't find any. So Dave sent a postdoc of his up there to go with that student, a guy named David Green, who's a Canadian from Montreal, who knows his frogs. And they didn't find any frogs. So it wasn't that the first guy was naive. And so then Dave Wake went up there and he couldn't find any frogs. So they were blinking out in California and in Costa Rica. And it wasn't just frogs. Again, in the late 80s, for those of you who may have been in Costa Rica, if you go over the high mountain Cerro de la Muerte, the hill or the peak of death, it's the highest point on the highway there. It's loaded with salamanders, or was. So every log you would turn over would have many salamanders. And in about the same time that in a different part of Costa Rica, the frog was blinking out, the salamanders disappeared. So Dave found tons of salamanders in 85 through 87, and then in 88, nothing. The following year, Dr. Wake was at the Smithsonian Tropical Research Institute, which in Panama, and talking with a biologist named Stan Rand, who I also knew well because he was mainly a lizard guy once he grew up and got out of frogs. But Stan had worked in Brazil and went back and found that frogs had blinked out. There were none. They were all gone. The frogs he had been studying that were abundant some years earlier were completely gone. So you have this really weird thing going on of animals in protected areas that were common that suddenly were gone. In 1989, there was the first ever International Congress of Herpetology, and there were many, many papers about frog declines. Again, a lot of this was stimulated and coordinated by Wake here in Berkeley, and the amphibia web that I referred to earlier is housed at UC Berkeley. So the question became, are there any patterns? What is going on here? Is it tropical animals, or is it highland animals, is it lowland animals, is it big species, little species? And it really wasn't known, but work workshops were approved and people started looking at this thing. And it's gone from, a handful of people studying an somewhat obscure group to a massive industry. There are hundreds of people now involved in this sort of animal pandemic. And it became quite popular, or it got popularized. The National Academy of Sciences had a meeting in February, I think February of 1990. And somehow word got out to the press. So the Washington Post, the LA Times, USA Today, NBC News, all the fake news organizations, sorry about that, got a hold of this, and it was fairly well publicized, and you might say the world became aware of the disappearance of these various animals. And some people didn't believe it. Many ecologists know that populations increase and then crash and then increase. And there was a lot of skepticism. In fact, in Dave's words, he might have been quoting someone else, the question is the sky falling? Or is this chicken little? The sky is falling, or is it Nero's fiddle? You're playing the fiddle while everything is burning.
Oh, yeah.
So in 1990, there was this trip made where Dave Wake and his group met down there with Karen Lips, whom we quoted right in the beginning, in 1990 down there in southern Costa Rica. This is a wave that went from this has been moving north to south, so not being totally organized here, but they found several species of salamanders, abundant frogs, and within a couple of years, Karen kept going back there. In 1994, there were no frogs. And she wrote a paper, for the quote came, it's called "Witnessing Extinction in Real Time." So it's really quite an astonishing phenomenon. And it's, as I mentioned, it's the salamanders as well as the frogs. It turns out that although by 1994 and 5, Karen was finding dead animals, it was another few years. It was in 1998 that it was discovered to be a fungus, a very specialized species of fungus called the Kittredge Fungus that attacks amphibians. It attacks their skins. And a slightly different species attacks salamanders, and it's very virulent in salamanders. Apparently, and if you do experiments and infect them, they just all die. My cameo appearance, I meet all these people. I didn't know it'd be a big thing, but so I'm putting this up here because it has my name. I was a co-author of one paper with Alan Pounds, who is the biologist who lives in Costa Rica. And another author was Jay Savage, who discovered and named the golden toad. And Michael Fogden is a great photographer. He's published lots of books of natural history. And this is a paper that actually is very statistical and not very biological. And I didn't contribute an awful lot to it. I'm the last author. But what we actually showed was this wasn't a matter of a population crashing. There was a lot going on simultaneously in a limited area. About 30 species of frogs declined severely in the Monteverde area in that very, very, very short period of time. And it was not until 1998 that the culprit was found. And by then, this became, everybody in the field knows about it. I mean, UC Press has published for our Fish and Wildlife, California amphibian and reptile species of special concern. So a widely known phenomenon. This, unfortunately, is tiny, but what it shows is the prevalence of this Kittredge fungus and its association with species declines. And what's really interesting is that, so you can look at the size of the bars, it's really, really most severe in Middle America, Central America, and South America, and Brazil. That's where you have these huge bars. There's really only a handful of species that have been really driven out in the US. It's basically not in, and Australia is losing some. And it's not just lack of study. It does not seem to be affecting, even though the fungus has been found, but it's like with COVID, where you can be infected and not, what are you? You're a carrier, but you're not symptomatic. So it's kind of very interesting story. Not fully understood. The ones that are blinking out are generally very localized, just like that golden toad. Tend to be small species, and they can go within, as I said, within a very short period of time. And I guess the bottom line is you can't lock up nature. You can't just put a fence around a protected area and say it's protected, because many, many, many things will play into it. So we have this fungus that's moving and measurable. It goes very quickly. Karen Lips was able to actually go down in Panama, south of where she'd been a couple years earlier, waiting for it, and she got it. She found it. It was moving miles per year. So I guess the question is there any hope? The answer is yeah, maybe. And what is really going on with the loss of these amphibians? I'll try to wrap this up. I'm talking too long. This is just another map of showing where the species are most affected by the amount of redness. And you see eastern US is pretty good and not too bad on the West Coast here. And it's really bad in tropical America. And it looks like they're now finding it in tropical Asia. So this must be a newer study. And I was aware. One of the interesting things, this is a graph that, here's what I find interesting is the way these things crash. This is in the Sierras. This is one of our ranas in the Sierras. And these are populations in various lakes. And basically, there'll be a lot, a few, and then none. These are just individual years. Each dot is moving across a year, and then suddenly crash, and they're basically gone. This would decline slightly, but it can be a real wipeout. And what is going on? Well, this Kittredge fungus apparently paralyzes the immune system, so the lymphocytes don't respond, and they just get eaten up. They get all kinds of horrible sores and scars and get eaten up. But it's not just Kittredge. So I'll summarize by just saying what is going on is habitat destruction that affects all kinds of organisms. Roads can be particularly horrible. Imagine a salamander trying to cross a road. I used to think when I taught at UCLA and we go in Southern California on Highway 10 that goes from Santa Monica to New York City. Imagine, this is a barrier, it might be only 50 yards wide, but imagine a tortoise or a salamander emerging alive from one side to the other. So you have isolated populations and habitat destruction. Introduced species are problems sometimes. Bullfrogs, which have been introduced because people eat them, eat smaller frogs, and they can explode and wipe out local. There are issues of climate change. There are correlations. There's no proof, but with warming, reproductive cycles can be screwed up, and also with drying out. These guys need moisture, even the ones that don't lay their eggs in water have to be in very damp spots. There's some question about ultraviolet B, UVB radiation, possibly. There are excellent studies from Tyrone Hayes, a professor at Berkeley in integrated biology, who's been studying various pesticides like Roundup and atrazine. They get in the water, and what they do, they seem to be pseudoestrogens. I don't really know the chemistry, but they feminize the frogs so that it essentially don't produce males, and that hurts the population. Then, of course, you have these diseases. And these things probably work in concert. In other words, as you're weakened, it's just like what we hear with the COVID. You die of COVID, you die of something else. As your immune system is compromised, the other thing gets you. There's a little bit of hope. Just a couple things. This is a fairly recent article in Science, just to show you how many people work. There's about 40 authors on this, but they're studying the catastrophe. And it also has an impact on communities, not just the amphibians. There's very good evidence now that there are neotropical snakes species that are primarily feeding on frogs, and they're getting wiped out. Their populations are plummeting. So this is a snake eating a frog. But when there aren't frogs, this specialized species is blinking out. So here's my 2 bits of hopeful. This is a poor slide, and I'm sorry in terms of the presentation, but the black is extinct and the red is presumed extinct. And these are years. And you can see that the curve has been flattening. I don't know how hopeful that should be. People are looking, and maybe the ones that were most susceptible and in small populations are the ones we know about. But at least the rate has been declining. So that's my little bit of hope. We also have saved some species in the Sierras who were being eaten by introduced predators, specifically fish. Certain species of trout were introduced, and they were introduced constantly. They're bred in hatcheries. And since they've stopped, since they've curtailed stocking these with fish, the populations have been coming back. So that was a very simple relationship between predator and prey. So there is some hope. There's some flattening of the curve. But there is this fungus that is spreading throughout the world. And I'm going to leave it at that. I guess we can take questions if you show me how. Or we can say.
Okay, George, I'm going to unmute everybody.
Okay.
And what I would like for people to do is to raise your hand when you want to speak, okay? And then I will, I have unmuted everyone, but please raise your hand and let me or George recognize you before you make your comment. And
I don't see anybody except you, Audrey. I don't know.
George, can you go up to the little?
Oh yeah, where is it? The little thing. Remind me of what little thing.
Okay, it's a little grid of 9 dots up there on the top of your.
Audrey, if he gets out of screen share, we'll see more people.
Go out of, get out of.
Oh, go out of screen share? Okay. You are screen sharing. Stop share. There we go. Oh, there are a bunch.
Okay, now you can see just about everybody who's there.
Okay, great.
Good.
Okay.
So,
as Roger's, oh yeah, Roger, you're waving your hand. Your hand is gigantic in this.
Right in front of the camera there.
are you trying to say you have a question?
I am.
I might not have an answer, but go for it.
Am I doing it the right way?
Yeah, you're
Oh,
doing.
yeah.
Okay, well, thank you very much, George. I really enjoyed that talk. It's really informative. One thing that really strikes me is about the rapid spread of the Kittredge fungus. And one thing that, I don't know if this is related, but we've had the experience when we went to Australia, for example, and even more so in New Zealand, that when you go hiking in one of the parks, you have to walk through this bath to disinfect your boots, because people carry all kinds of stuff from one place to the other. Do you think that is the way that the Kittredge fungus has gotten spread?
Well, it's quite possible. In fact, one of the, I didn't mention this in the talk, but the pet trade, you wouldn't believe the numbers of salamanders that are imported for aquariums and pets. It's hundreds of thousands, and they are often Kittredge infected. And then there's the people who are collecting these things to eat them, and they end up in restaurants. And then there's the biologists like us who are tromping through and not. I noticed that in New Zealand, we were just there a couple months ago, and that you had to disinfect your boots.
Yeah.
So I think all of those are, I think the pet trade and the restaurant trade and the general collecting from place to place is probably responsible. Yeah.
Oh, okay. All right.
So George, are you saying that that someone could eat an infected frog or salamander and then pass the virus on?
No, I'm not saying that. I'm saying that they bring them in, they keep them in tanks, they let these things go. The people who dump frogs into streams, there's the African clawed frog lives in Southern California now. So no, I wasn't saying it was ingested.
No, okay.
It doesn't seem to affect people, but it can be spread around easily. And there are huge controversies. I mean, science being science, the article in that one of my slides with those 40 authors and the panzootic thing, and then there was an article a few months ago saying, well, you didn't really prove it, blah blah blah, and then there's another article saying, yes, we did. So, in other words, there are correlations, and you can experimentally definitely infect these animals, but there's still arguments about what is the primary cause, and it's probably the synergy of all the things that are going on. But the most shocking is that these animals in pristine areas in national parks and protected areas can blink out in a few years. They're just gone.
Wow.
So it's been amazing.
Anyone else have another question or comment to make? You don't have to, you can talk among yourselves now. You don't have to direct everything to George.
Right.
We want to make this a discussion. So Charlie wants to say.
George, you emphasize that this phenomenon is taking place in these protected areas, like something's getting over the border, but how about the areas right around the protected areas? Is the protected area just happened where you sample and it's representative of something much larger, or something different in the protected areas?
No, I don't think it's worse in protected areas. I think like Monteverde Cloud Forest is a famous area, so people go there to look, the biologists go there, and so they find things. But I don't, in other words, it's in spite of protection, not because of the protection. I don't think things are worse in protected areas. I didn't mean to imply that.
Okay.
It's just people are sort of amazed that in these famous pristine areas, that's where things, but that's where biologists go to study creatures.
So maybe this is all caused by biologists?
That's right. Not all, but it could be. No. As Roger said, you go from place to place in your dirty boots, and you're on a field trip from one country, and then you knows.
Yeah. Well, in back before humans were living so close to one another, they didn't have contagious diseases. But then, so I was wondering if these frog populations are very isolated, then how is this virus or this fungus getting transmitted? And it could be biologists then, but not by one frog going to another's neighborhood.
I don't know. I mean, I do think it is one frog going to, because these things are spreading faster than biologists. The wave in Central America was measured in, miles per year. They're able to track it. Yeah, we might be culprits in part, but I don't know enough about the spread. Sam, I see you're there. I'm glad you're feeling well, and I want to thank you for your help, even though you're muted there.
I can unmute. He should be unmuted. I thought I unmuted.
Well, he's muted, but that's okay.
Okay.
Maybe chose to be muted.
Yeah, maybe on now.
Good to see
Oh,
you.
yeah, yeah.
Good. That was excellent. Thanks a lot. Sure.
Well, thank you for
Mhm.
helping organize some of that stuff.
So are there any more comments or discussion about this?
Sarah, something, Sarah, if I'm reading right, yep.
Sarah, you need to unmute yourself.
I can't hear her.
Right.
It doesn't say she's muted.
Now you're unmuted.
Yes, right. I just wanted to say that even though I was interested in the scientific theory behind the disappearance of these amphibians, I also just wanted to comment on my joy in seeing how varied they were in coloration. And some of them are just beautiful, and also, yeah. So it was just a joy to think of the wonder of the different species. So thank you very much.
Oh, yeah, you're more than welcome. And yeah, I feel they're an underrated, underappreciated group.
Yes, yes. I used to be a docent at the Audubon Canyon Ranch. And
Oh, okay.
so, and the kids would just love to carry around the different salamanders.
Right.
Yeah.
Right.
This
Right.
may be a little bit of black humor, but is there a correlation that the more beautiful we find them, the more poisonous they are?
No, that's a definite correlation because it's warning color. It's for visual predators. So birds won't touch them. So yes, if you're going to have those brilliant, I mean, if it's not camouflage, if it's the opposite of camouflage, it's usually because you're distasteful. That's true with bugs and many creatures. So, go ahead, Roger.
Yeah, I got one other question I wanted to bring up, which is kind of a more general question, is about this concept of homing of these. I was really amazed that the newts would go back to their natal pond. But this is a phenomenon you find in a lot of different species. And I'm trying to think about what would be the evolutionary advantage of always going back to, because we have the salmon coming up after 3 years at sea, they find their way back to their home stream and all that sort of thing. And I guess, it's tried and true. You could say that, maybe they were born there, they're healthy, they came back, so it might be a good place. Maybe you don't want to take a chance on going anywhere else. But on the other hand, going to different places, and I mean, this is something humans are pretty good at, is trying out different environments and maybe being able to spread and adapt to different areas. So it's just kind of a general question.
That's interesting. I mean, obviously, for a population that have some geographic dispersion, they're not going to be perfect in where they're going back, right?
Yeah.
So I guess, I agree that there was a pond there. So if you can have that smell in your nervous system and go back, there's probably going to be a pond there as opposed to a random walk. But yeah, you definitely, if you can't disperse, there's going to be extinction.
Yeah. With birds, there's lots of examples of birds that migrate thousands of miles every year.
Yeah, I know.
And then they end up in the exact same patch of forest in Costa Rica or wherever, and that they came from. And it's always quite amazing. But on the other hand, we went to a talk one time about the Farallon Islands off of San Francisco here, and they talked about the bird list for the Farallon Islands. And you'd think, well, Farallon Islands, it's going to be some seabirds, some shorebirds, probably not a huge number. Actually, they had something like 450 species of birds that have been found in the Farallones. I say, how the hell could that happen? Well, the answer was the birds were lost.
Right.
And so the birds are flying, trying to go somewhere, and they get blown off course.
Yeah.
And there's fog and they don't know where to go and they get tired and, oh, good, look, there's someplace. And then they go down and land on the island. So, you know, that kind of mistake, you know, in that case, it's not such a great idea for most species. But, you know, if you don't have a chance to try out something different, you know, how's the species ever going to? So,
Yeah.
you know, I guess it's just good that, you know, shit happens, you know, that.
Well, it's like mutations. Most of them are bad, but some, it's only because of mutations that there's genetic evolution and, you know.
Yeah.
Yeah, but it's very, I mean, birds have a real advantage. I mean, you know, that's right.
Sure.
They can look around and see land and I'll go there.
Sure. Yeah.
Well, you know, the other thing is that most animals have a range.
Right.
And so within a range, they may have variation in the range and different ability to thrive in one part of the range. And so if conditions change in the warmer part of the range, but there's still a better part of the range, then they can survive there. And so, you know, adjust or mutate or whatever.
Yeah, I read the Newt stuff years and years ago, and I mean, it was kind of horrendous, the stuff he was doing to them, but they find their way home.
Sounded terrible.
Yeah. It wouldn't even be legal now.
No.
Well, we all suffered by the closure of that Newt Road up in Tilden, you know. It's we always have to drive out of the way to get to where we're going.
I love it. We love it.
But we've come to understand that the newts are important and they have to do their migration. You know.
Right.
Yeah. Well, maybe we can trick them into a newer and safer route.
Yeah.
Well, good. Well, this has been fun for me. It's been very stressful, and I've learned a lot, and I've had help from technical help, which I appreciate. Reviewing some of this stuff that I was doing 30 years ago is fun also.
Well, thank you very,
Right, great.
very much, George.
Thank you.
It's been
Thank
very
you,
nice.
thank
You
you.
put a lot of work into it, and I appreciate that. I
Great.
just want to tell the rest of the people who are here that we have Ken Nakayama is going to prepare a talk for us on face blindness for July. So this is an area of his expertise. He's a former professor at Harvard and has studied that and other things. And so I think we'll have another very interesting talk.
I think it should be very interesting to those of us who have trouble recognizing people.
Yeah.
Isn't that the case? What's your name?
Yeah.
Do you know what date that is?
The 12th, is it the 12th? It's a Wednesday, the second Wednesday of the month.
Okay, cool.
So I'm looking at that. Let's see, June. It's the 8th actually. 8th. Yeah.
All right. Well,
Okay.
we're over this.
Oh, and I want to say again that the Science and Ideas interest group runs on the energy of their participants. We run on ideas. If you have an idea, some interest of yours that you find intriguing, for Pete's sake, volunteer. You can, you can look up more stuff on it, follow some inclination of your own, and come up with something that others would also be interested in. So please don't be shy.
Can I comment on the backgrounds I'm looking at?
Oh, sure.
You know, saying Roger seems to be in the Caribbean there. Francis seems to be perpendicular to the ocean.
I get rid of this background. When I was hosting it, I could do it. Now I don't know how. It's sideways. It's San Francisco sideways.
It looks like you're sideways.
Sorry.
All right.
Glad you showed up.
Thanks.
I loved it. Thank you, George.
Okay.
Yeah, thank you.
Okay.
Thank you, Art.
Thank you, George.
Bye.
Bye-bye.
Okay. I think I know how to make it disappear. Bye-bye.
Don't make us do
I will.
it. Audrey knows it.
Goodbye, all.